Okay, so again, my name is Jerry, and I'm here to introduce our speaker tonight. And welcome to the first session of the semester. So we're glad you're here. The speaker today actually volunteered to do this last night. We had a last-minute change, and he was able to step forward, and we really appreciate Ho-Chin coming in and working with us on this. Ho-Chin Ding is a fourth-year PhD student in computer sciences. His advisor is Chunyi Ping, and his interest area is in mobile networks. And today he's going to talk to us about combating caller ID spoofing on 4G mobile phones. Now, I saw part of his, or listened to part of his recording, and I think I've heard that exact recording on my mobile phone many times. So with that, I'll turn it over to Ho-Chin.
Thank you very much for the introduction. Good afternoon. Today I would like to present our work, which is called CEIVE, which is a victim callee-only solution against the caller ID spoofing attack, but without requiring any additional infrastructure support or any change on the existing telephony system. This started with a real story. One day, my professor received a phone call from the Chinese consulate, and it claimed that she was involved in money laundering and asked for some banking information. Yes, it was a scam. Professor knows it, and no money is lost. But not everybody knows it. Someone didn't know. So there was a news in June last year that somebody lost $3 million. Not only him, there are many other victims. Actually, the consulate scam has been reported in many places, like the Federal Trade Commission, FCC, Chinese consulate website, Washington Post, CBS, and many places. So in US, Federal Trade Commission has already confirmed that imposter scam is again the top fraud. 1 out of 5 American people suffers from this scam. And the average loss increased from $274 to $720. So scam call is already a big threat to people's daily life, and it's growing at an alarming rate. It happens not only in US, but globally. Such scam has been reported in many other countries. So all of these are actually caused by caller ID spoofing. To understand how it happens, I would like to give you some background about how we make a cell phone call. Actually, it is very simple, just 3 steps. So first, the caller, Alice, will send a call setup request to callee Bob. And this request needs to carry the caller ID information, which is the phone number of Alice. And then more signaling messages are exchanged between Alice and Bob to set up the call session. Once the call session is set up, a voice conversation can be started. Unfortunately, spoofing is also very easy in this case. So a malicious user, Eve, can just change the caller ID carried in the call request message. For example, Eve can just use anybody's phone number like Alice's number, then spoofing is made. What even worse is there are so many public tools available, and anybody can make a caller ID spoofing attack in minutes without at no cost. Unfortunately, we found it is hard to defend spoofing. There are 3 types of solutions proposed. So one of them is using a global certificate authority between Alice and Bob. But this has a heavy deploy requirement and requires updates on both caller and callee's carrier network. Another one is called the challenge and response method, but this also requires change on both Alice and Bob's side. There are also some caller ID applications that put effort to tag scam number, and you may already know it, like the Google caller ID application. But this kind of solution is based on phone number search and user report. It doesn't work for any new scam number at the beginning. So what kind of solution do we really need? Actually, what we need is a Callee side only solution, and we don't want to change and to do any change on the existing telephony system. Can we do that? Yes, we can. And here I propose the CEIVE, which is our solution. So let me first give you the basic idea of how CEIVE works. So the idea is like this. When Bob receives an incoming call from Alice, he has no idea whether it is really called from Alice or just spoofed by Eve. But what Bob can do is he can make a callback to Alice. We know the network is not compromised, so this call will definitely reach Alice. And then Bob can try to verify to see if the same party Alice is involved in both call sessions without get an explicit response from Alice. So this is done by comparing their call state. So in this example, when the true caller calls Bob, Bob knows that the true caller currently is in the dialing state. And through the second authentication call, Bob can learn that Alice is actually in the idle state. Then we can see idle state is different with dialing state, and spoofing is detected. So it turns out this problem is how can we infer Alice state with Bob's view only? And this is not that much easy. So we tried all the related information provided by Android operating system like call state, precious call state chain, system log, all the API we have. But we found that none of them work because all these are only related to the call state of local device, Bob, not the opposite party, Eve or Alice. But actually, we found that the call setup signaling message can help. Recall the call signaling message is the one we used to set up a call session. So today's 4G phone supports two kinds of call technology. One is voice over LTE, which using IP data packet to make a phone call. And the protocol it used is called SIP, Session Initiation Protocol. And another one is the CS fallback or CS call, which use the traditional circuit switch. CS stands for the circuit switch to support the phone call. And the message used to make a phone call is called call control message. And our work showed that both can work with CEIVE. Here I will use voice over LTE to illustrate our idea. So now let me use this example to show you the feasibility. So let's assume that both Alice and Bob are using T-Mobile voice over LTE. And we consider three scenarios. So we want to show that whether these signaling messages are different when Alice's state change. So in the first case, this one is the normal case, while Alice is the real caller and Bob may call back when Alice is in dialing state. So now let's look at the signaling message observed by Bob. At the beginning, there are some common message for all SIP calls, so I will just ignore them. And then Bob will send, in the beginning message, Bob will send an invite, of course. And then we can see Alice will use 180 ringing message to indicate that she have already received the invitation and is alerting for this call. And then the 200 OK corresponding to invite, if you can see it, this will indicate that the call is successfully established. And finally, Bob will send bye message to shut down this session. So here we know Alice is currently dialing when Bob makes the authentication call. So the established session actually means Bob is entering into Alice's voicemail. Now let's look at the spoofing cases. So this one is when Bob receives a spoofing call from Eve and makes verification call when Alice is in idle state. So after the same common message sequence, this time Alice will send a 180 ringing message but with different value in the PEM field. So PEM field indicates the desired direction of some earlier media string. An earlier media string is something like a customized color ringback tune. So send and receive here, send and receive means that both Alice and Bob could send these early media streams, while the send only, which is in the previous case, it indicates that only Alice will send it. So this time, the call session is not established. and Bob sent cancel message to shut it down and received 487 requests terminated as a response. The last case is also a spoofing case, and this time Bob made an authentication call when Alice is in connect state. So this time, the 180 ringing message includes alerting information. You can see there is an alert service call waiting. So this indicates that Alice is currently engaged in another call and gets notified that a new coming call from Bob is arrived. So if we comparing these three cases together, we can see that the call setup signaling sequence varies when Alice call state changes. So that made us believe that inference could be possible. That was some details. So I would like to give you some high-level idea about why this kind of information could, why this solution works. So the idea is actually pretty simple. We know the standard defines a rich set of signaling message that can carry rich context information. Like, for example, in the SIP protocol, as I showed you, we can have the SIP response code, which is 180-200, this kind of code. And we also have the PEM field. We have the alert information. All these combined together would construct a finite state machine for a voice LTE call. And it could give us enough hint to infer the Alice's call state. So now I can give you the general procedure of how CEIVE to show how it detects a caller ID spoofing. So CEIVE is installed at Bob's side. When receiving an incoming call with Alice ID, CEIVE launches an authentication call to Alice and keeps monitoring the signaling message exchange. Then it uses a pre-learned call state classifier to infer the Alice call state. And given the call state of Alice and the caller, CEIVE can give the final detection result. It's pretty straightforward, right? But we found that it's not that much easy. When we extend our experiments to more carriers, we find some trouble. The challenge is, although the standard stipulates the mechanism, it still leaves options for vendors and carriers. That means carriers could have their specific implementation. And due to this, when Alice and Bob's are used in different carriers or various carriers, the call setup signaling message are also different. So for example, when Alice is currently in dialing state but use different carriers like AT&T, T-Mobile, Bob could observe totally different call setup signaling message. Here is a case. So all these three cases, Alice is in the dialing state, but use AT&T circuit switch fallback, or use Verizon voice over LTE, or even use a single line landline. And we can see the signaling message observed at Bob's side are totally different. Even worse, it can also lead to the call state ambiguity issue. So the idea is that Bob could observe the same signaling message when Alice is in different call state. For example, this one, Alice is in the dialing state using AT&T CS fallback. But in the idle state and the connected state, we can see Bob will always observe the same signaling message. Such call state ambiguity makes it hard to accurately infer Alice's call state, and this is fatal to CEIVE. And there is another challenge, which is advanced attack if Eve is aware of CEIVE's strategy. So for example, Eve could try to manipulate Alice's call state by making another call to Alice when attacking Bob. For example, if Alice is also being dialed by Eve at the same time when Bob makes the authentication call, both caller and Alice are in dialing state. Then there is no way for CEIVE to detect if it's a spoofing attack or not. So to solve these two challenges, CEIVE is equipped with some special design in the call state classifier and the spoof verifier modules. When CEIVE do the initial training for call state classifier, we extend the call state label from a single call state to a unique combination of single or multiple call states, and also include the caller and the callee's carrier and the call technology information. For example, after we use some terminology to extract the useful information from signaling message, let's say we can get 5 different patterns. And we found that P1, P2, and P3 are observed when Alice is in dialing state. P4 and P5 are observed in connected state. But however, P5 is also observed when Alice is in idle state. And this caused the call state ambiguity issue, right? So to solve it, CEIVE will match every pattern to a unique label like this. For example, for pattern 5, CEIVE matches it to the combination of 2 states, connected and idle states. So this method guarantees that a unique pattern is always matched with a unique label. And I will show you how CEIVE can benefit from this approach later. And in the spoof verifier module, CEIVE do verification through 2 phases by making 2 calls. It makes the first one when Bob received the incoming call and the device starts ringing. And it makes the second call after Bob answers this call. So the caller state in phase 1 will be dialing and in phase 2 will be connected. This table summarizes the call state of Alice under totally 7 scenarios. So we totally consider 7 call scenarios. So C1 is the normal case, just Alice, the real Alice call Bob. And C2 to C7 are all the attacking scenarios. So we can see in C1, Alice is dialing in phase 1 and connected in phase 2, which is exactly the same as a real caller because Alice is the real caller. But in C2, C3, and C4, these are 3 basic attacking scenarios. And we can see none of them is dialing in phase 1. So that means in phase 1, CEIVE can already easily detect it's a spoofing attack. And case C5, C6, C7 are the advanced attacking scenario in which Eve will try to manipulate Alice's call state by making another call. But given this 2-phase verification strategy, we can see none of them could make Alice's state to be exactly the same as it is in the normal case 1, like dialing in phase 1 and connected in phase 2. So this makes us believe that 2 phases strategy is already good enough to make a spoofing detect. And in each one run of verification, CEIVE will keep monitoring all the call setup signaling message and end the verification call once it gets enough message to infer the call state because CEIVE don't want to bother users too much, like you don't want to make a phone call and keep ringing at Alice's side. After comparing the call state from caller and Alice, the verifier will give 4 types of output, depends on the comparison result and which phase it's currently in. So the decision tree of this 2-phase verification strategy looks like this. So if Alice's state and the caller state are not matched, spoof is directly detected. If they match, but it is not the last phase, the output is to be determined and continue to the next phase. If it's already the last phase, CEIVE will check see if there's any call state ambiguity. If no, the caller ID is verified. Otherwise, CEIVE cannot make the final conclusion. So this 2-phase verification strategy not only define the advanced attacking, but also reduce the likelihood of giving a NA conclusion caused by call state ambiguity. And I will use an example to show you how. So consider we have the following call state inference result. Let's say in phase 1, Alice is inferred that it could be either connected or dialing. And in phase 2, Alice could be either idle or connected. Although there is a call state ambiguity, but given the extra information contained in the label, we can find that this can only happen when Alice and Bob are both using carrier 2 voice over LTE. And such implicit carrier information could help CEIVE to reduce the call state ambiguity and give a correct verification result. CEIVE also are equipped with some other components, and I will just give you a brief introduction. So it will need to have a support for relearning to learn some specific patterns of a new carrier, and also have some timers to make CEIVE be responsive to make spoofing detection and be friendliness to both Alice and Bob. And we also have some smart triggers So that, for example, if the incoming call is from the contact list already, so we don't need to verify it. And also, if both Alice and Bob have CEIVE installed, we don't want to have a loop, like both of them keep making call to each other. So now I will show you some evaluation result of CEIVE. So, so this is just a video. So we can see that for the consolidated scheme call, the left one doesn't have CEIVE installed, but right one have CEIVE installed. So user will be warned when CEIVE can detect that it's a spoofing attack. And I will show the results regarding detection accuracy and the delay here. So let's first check the accuracy. So we consider Alice to use 4 major US carriers and 1 single line landline telephone, which is in the column, the leftmost column of Alice, and also 2 call technology if it's supported by the carriers. And we check the accuracy over all these 7 call scenarios. So here's the result when Bob is using voice over LTE. It's only supported in T-Mobile and Verizon in the United States here. So as we can see, that CEIVE can achieve 100% accuracy as long as it can give the verification result. But for scenario C1 and C7, due to the call state ambiguity of idle and connected states, CEIVE could not give the detection result. And these are one of the limitations of CEIVE in our current implementation. And next, I will examine the user friendliness and the responsiveness by measuring the inference delay. So we measure the completion time of inferences in 2 phases. So in phase 1, the time will be once the cell phone is ringing till CEIVE can give the first state, the first phase inference. And the second phase is once the user Bob answers this phone till that CEIVE give the final decision. So let's see the time cost in these 2 phases. So for the completion time for the first phase, user needs to wait 4 to 10 seconds using voice over LTE, and which is faster than the circuit switch fallback, which usually takes 8 to 10 seconds. And this is just because CS fallback usually takes more time to initiate the phone call compared with VoLTE. And for spoofing call, that 1 phase is enough to detect. That means CEIVE can finish it within 10 seconds. And we also measure the total completion time for CEIVE to give a verification result. So for 2 phases verification, in most cases, CEIVE can finish it within 16 seconds using VoLTE and 19 seconds using CS fallback, but no more than 23 seconds. So as you can see here, CEIVE can yield a timely verification. It can alert the user before the telephony fraud causes any real damage, because I don't think that within 20 seconds you will pay some money to the attacker. But of course, one thing I need to mention here is that one of the biggest limitations of CEIVE is that it doesn't work in the case of multiple line telephone number. We know that there are some telephone which is not cell phone. It has multiple line, like for example, the phone used in organization, like in a company or in a school, because people can use the same phone number to call in, but when the guy inside the organization to call out, they have different phone numbers. And these cases, it's called a multiple line telephony system. There is a proxy in between. So in this case, the idea of CEIVE doesn't work. In summary, I introduced a solution which against the caller ID spoofing, which is use Callee's capability only. And I formulate the problem into a design as inference and a verification problem. And to solve it, the core idea in CEIVE is exploit the call setup signaling message to infer the call state and make the verification. So that's all about my presentation. And thank you. I can.
Yeah, sometimes I notice when somebody is calling and I'm not answering. When I call back, that number is not in service. So did you consider that kind of a situation? Or because all these things, you say maybe they got it from your contacts, but sometimes it just say it's not even in service. Somebody is calling you, you don't answer it, You call back, it's not in service. So how does that one work with what you're saying?
Actually, if you have CEIVE installed in your device and someone is calling you, not answer it, if in phase 1 it's enough to see if the incoming call is a spoofing or not, CEIVE will show you. But if it's not enough, unless you pick up, you answer the phone, CEIVE will not give the final detection. So CEIVE can only guarantee that once you answer this phone, it will 100% it will definitely give you a detection result to see if it's a spoofing call or not. So
something might answer it. They call again and again and again, except if you stay on and push a number so that they don't call, but they see they call. So.
I see. Actually, in this case, CEIVE will not say block an incoming call. It's just trying to see if the incoming call is really from the phone number it's claimed to from. So CEIVE will not like tag it as a scam call and block it. I think this kind of function can be supported by some caller ID application. Like if you keep receiving a phone call from a specific phone number, and the other people also receive the call from this number, and other people, they reported that this is a scam because when I answer it, it says nothing. Then the caller ID app will see, okay, you are receiving a call, which is very possible that it's a scam, and then it will block it for you. This is, I think it's already implemented in some caller ID application, but it's not what we want to do for CEIVE.
Yeah, but basically, if I answer, I don't answer. The thing is, sometimes you are driving, somebody's calling you. Usually there is no messaging, just calling you. And basically, if you answer, you don't answer, and usually it's very close to your number or in your vicinity. That means the area code is a local area code, and basically the other one, some of the prefixes that you have for local numbers. So you cannot detect it by looking at it that way. But as I said, that's my experience. I don't know. I thought I'd let you know.
Actually, I read some news that why you see those numbers incoming from a local area. It's because they believe that you are more likely to answer this number. This is what they try to do actually for today's some scam number.
Yeah, but the thing is, they are not even listed. They said if you call it back, they said this number is not available.
No, it's available. Actually, it's the idea behind this kind of scam call is exactly the same as a spoofing call. The idea is they are using some like a computer, a server. They will send some zip message to make it look like a phone number, and make a call to you. But in this case, if CEIVE is making an authentication call back to this phone number, it actually can get through. And in most cases, it will show that one is idle or other states, but it will never show like in the phase 1, it will be idle, in phase 2, it will be connected. That's not possible.
No, what I'm saying is when you call the number back, it said this number is not in service.
It's all based on chance. So they'll spoof it to a random number that's similar to yours. Sometimes the number will be registered, sometimes it might not.
No, it usually is not even, as I said, all the time that I called back, they said this number is not in service. So it doesn't belong to any particular person. It's not random. It is just doesn't exist. It's not in service.
Yes, but actually, so let's say when the phone number is not like you don't know the phone number, for example, the phone number is just some random number, and in this case you won't. I think a scam call is hard to make you to believe like this is some big important issue, because you know it's most likely nobody is calling me. But when this phone number is important, like what I show you in the previous slide, there was some news. All these phone numbers are from like a police station, a consulate, and this kind of phone number makes people believe that, okay, this is a real number and this is the real guy who is calling me, and he asked me for my like important personal information, and people will tend to believe them.
No, I'm saying that how you are going about it, you are assuming it is from your list of numbers that you have, but all the numbers that I've called, they said this number is not in service. So what does that tell you? That this is not random. They are choosing the numbers which doesn't exist, doesn't belong to anybody.
Yeah.
And what they are doing, I don't know. I thought I'd let you know, so maybe you can come up with something for that. But yeah, well, thanks.
You mean you're asking if the number doesn't exist, what will happen?
Yeah, I said the number is not in service. It's not that I called some number and they said somebody answered it. 100%. I called those numbers. They said this number is not in service. So I thought you should know this one too. What as I said, because this is not random. You are choosing it from the number which are not in service.
Okay.
Yeah. Okay, I thought I'd let you know. So if you want to do some research on that one, you're welcome. Thanks.
Yeah, thank you.
So how did you guys get access to interface with the low-level protocol signaling data? Does the OS expose those signals?
Oh, actually, the operating system, like I said, Android OS doesn't support this information. But since I'm a CS student, I work in the mobile computing area, so we developed some kind of tools which can help us to extract this information directly from the hardware chipset. That's actually the tool is called Mobile Insight. We can get the call control message, and for the SIP message, it's even easier if you use some TCP,
Wireshark, maybe?
No, not Wireshark, the PCAP. You can store the PCAP files. You can collect using TCP dump to collect PCAP file, and you can see the SIP message.
Quick question: if you are using your software on a cell phone and you get a call from a multi-line number, let's say an Apple contact support number or a bank registered number where you have the contact in, and it goes through the process and it's trying to check those statuses of every single one of the C numbers, would it give false positives saying it's a spoof number if that number would be in multiple statuses?
Actually, it will.
Yeah.
Because we do have run some experiment against the phone number at Purdue CS department. We check and we can see that the reason is because you can make multiple calls to the same number, and the same number will be in the idle state, and someone could pick it up. In this case, we will see, okay, it seems like someone is really calling you, but we just admit that this is a limitation of CEIVE, and we don't include this into the evaluation. Yeah. Thank you. And if you are interested, I can show you a demo, but today I don't have usually when I show the demo, I use multiple phones, but today I don't bring those phones with me, but I can play a video for you too, if you are interested.
Here's our attack and defense demo to show how CEIVE successfully detects a real caller ID spoofing attack. The real spoofing attack is called the consulate phone scam. It was recently reported and targeted to Chinese people in the US. When you receive the call, it sounds like this.
中国驻农领事馆最后一次通知，您有一封紧急重要文件，其将影响您的出入境。
Someone didn't realize it was a scam and lost $3 million. Such imposter scams have been reported in many places. Now we show how CEIVE successfully detects caller ID spoofing on the Callee side. We use two phones in this demo. The left one plays as the attacker and the right plays as the victim. First, we enable CEIVE on the Callee side. Now we show how easily a caller ID spoofing attack can be launched. The attacker uses a mobile app to make a scam call. There are dozens of Android apps available. Here we choose SpoofCard. SpoofCard asks for the number to call, so the attacker gives the phone number of the victim. Next, the attacker specifies the caller ID to display on the victim's phone. Here we input the phone number of the Chinese consulate general. Our spoofing attack is launched by a simple tap. After a while, the user receives an incoming call. The caller ID app shows that the phone number belongs to the Passport and Visa office. Within seconds, CEIVE gives a warning that the incoming call is a spoofing attack. Given such an alert, the user realizes it is a scam and ends the call directly. There will be no victim today.
Thank you. Mm.
Did you face any issues on the false positives also?
Pardon?
Did you face any issue regarding the false positive also? Let's say
Go ahead, use your mic.
somebody from a so did you face any issue regarding the false positives also, as in somebody from your caller, as in some from your contact list is calling you, and then you got a message, then this call can be spoofed or something sort of that?
Actually, what we do in our implementation, we just don't do any check against a phone number in the contact list, because we believe if it's already on your contact list, you know this person. From the conversation, you can know if it's a spoofing or not. So we actually, you may asking about found some false positive prediction and try to like correct it. What we did is, if there is a new carrier we haven't learned before, for example, in the US we trained all the 4 major carriers: AT&T, Sprint, Verizon, and T-Mobile. But the time when I attend the conference, I fly to India. And in India's carrier, we found they totally use different patterns, signaling message, and our previous solution doesn't work at all. And at that moment, I need to make CEIVE to train for these new carriers to make sure we consider all these cases together and make the inference and the verification. Yeah.
Okay, anything else? All right. Well, thanks again.